The topic of this video is graphing transformation techniques, vertical and horizontal stretching and shrinking. Okay, let's look at a problem. Graph the function f of x equals the square root of 2x. Alright, so this is where our knowledge of our library of functions, of our basic functions, comes in so handy. This very closely resembles our basic function f of x equals the square root of x, also known as the square root function. You should have all of its coordinates perfectly memorized from memory, and you should be able to create this table of points just as quickly as I am right now. So this is where we're starting, and if I wanted to make a quick sketch of this particular function, here's what it would look like. That is the square root function. Now our job is to figure out how is the square root function equation and this function equation different. And we can see obviously that the difference is the 2. And so this brings us to two very important questions. First of all, is the change inside close to x or outside far from x? And the answer to the question is, it is inside close to x. The change is inside close to x. And from that we conclude that the transformation here is horizontal. Next, what kind of change is it? Certainly there's a 2 there, but what's it doing? Well, the 2 is multiplying. And the fact that it's multiplying is indicative of a stretch or a shrink, and we have to figure out which one. So let's see if we can do that. Let's see if we can put this together. The first thing I want you to understand is that this is horizontal, and horizontal shrinks and stretches behave backwards of what you would expect. So you would think that with a number like 2, which is more than 1, that would be a stretch, but it is the opposite of that. It is a shrink. This is a horizontal shrink. Now, whenever you are dealing with a horizontal stretch or shrink, the way you get your new coordinates is by dividing all of the x values by whatever this number is. So we are going to divide the x coordinates by 2. The y's don't change. Only the x's change. The y's are still going to be 0, 1, 2, 3, and 4. But the x's are going to change, and they're all going to divide by 2. Okay, great. So 0 divided by 2 is 0. 1 divided by 2 is 1/2. 4 divided by 2 is 2. 9 divided by 2 is 9/2, also known as 4.5 or 4.5. And 16 divided by 2 is 8. So what we're going to see here is that the entire graph of the black curve is going to shrink towards the y-axis. And so the end of our picture is going to look like this by comparison. Every point on the black is moving horizontally towards the y-axis. Okay, let's create our graph. Let's use the new coordinates to create our graph. So the y's need to go all the way up to 4. So there's 4 and 2, and there's 1 and 3. The x's need to go all the way out to 8. So if that's 8, halfway would be 4, and that would be 2, and that would be 6. And now we can plot all of our points. So here we go. So 0, 0 is here. 1/2, 1 would be here. 2, 2 would be here. 4.5, 3. So if that's 4 and that's 5, 4.5 would be right there in between. And 8, 4 would be here. When we connect all of those dots together, we get ourselves the graph of f of x equals the square root of 2x. Now, just for perspective's sake, I would like to now take this black graph, the square root function, and plot these points on top just so you can see by comparison. We've already finished the problem. This is it. We're done. This is our final answer. this blue curve is our final answer. But let's put both of these graphs on the same graph grid. So 0, 0 here, 1, 1 is here, 4, 2 is here, 9, 3 is just barely going to fit on this graph. There's 9. So 9, 3 is here. And you can see what's happening. The points from the black are moving horizontally towards the y-axis. This is indeed a horizontal shrink. The points are moving, they are shrinking towards the y-axis. Okay, the blue curve is our final answer, and that is the end of this problem.